This is Cameron Chai from ASOM.com on behalf of VCAMM, coming to you from the Carbon Fibre Future Directions Conference in Geelong, Australia. The conference has been organised by VCAMM and Deakin University and is sponsored by VCAMM, Deakin University and the Victorian State Government. Today I'm speaking to Professor Andrew Walker, who's the CEO of the National Composite Certification and Evaluation Facility in the UK, and I'd like to take this opportunity to welcome Andrew to the program.
Hello, good morning.
So Andrew, could you tell us quickly what the National Composite Certification and Evaluation Facility and what is its function?
Okay, well, NCEF is based at the University of Manchester, and its purpose is to promote the development of composite materials, the transition from metallic materials to composite materials, which we see happening over the next 10 and 20 years, and it's all driven by the cost of energy and the need to replace heavy metal transport systems with lightweight plastic transport systems.
So that's what you think the drive is, obviously, behind developing composite materials and their integration into, for instance, the commercial aircraft industry?
That's right, and the purpose of my group is to ease that transition from one industry to another industry. And so we need to develop standards for materials, processing technologies, design parameters, so that people can easily adopt these new techniques.
So you perform a function similar to what VCAMM do in Australia, facilitating getting the knowledge from R&D through to industry and developing collaborations between the two?
It's not quite the same, because in many respects VCAMM is a true facilitator, whereas we are, our job is to deliver composites. So VCAMM can work across a broad spectrum of science and engineering, and we only work on composites.
So you'd be similar to a VCAMM, but in that area of just composite materials?
Yes, I guess they're one step closer to government than we are.
Okay.
And we're slightly closer to academia.
And so you also see there's a correlation between the price of oil and the price of carbon fibre materials?
Yes, because carbon fibre is derived from oil. However, the demand for carbon fibre will rise as the price of oil rises, because it's all about the cost of energy, and low mass systems burn less fuel. And we hear how that just the previous speaker was talking about if you can save 10% of the weight of the car, you can save about 10% of the fuel burn. So if you're reducing the car by 10%, 100 kilos equals $3,000. So you can afford $30 per kilo per car material. So that's where it comes from. For aeroplanes, it's different. It's generally $3,000 per kilogram saved. So it's two magnitudes larger for.
So the savings and the impetus is much greater for the aircraft industry then?
The impetus is greater in the aircraft industry, but the volume is greater in the car industry, and the two go together. So
we've seen some of the car manufacturers, mainly sort of the exotic car manufacturers, moving largely towards carbon fibre chassis and bodies and things like that.
Yeah.
We've now seen people like Boeing and the 787 and moving towards composite fuselages. And how long before we get a much greater uptake with the aircraft industry?
Well, that will come very, very rapidly. The problem is with the aircraft industry at the moment is that no one makes a profit. So if you go to a carbon plane, you save about 30% fuel burn. So a single aisle aeroplane, which costs $65 million a year to purchase and burns $20 million of fuel, we could save $6 million of fuel per year if we had a carbon variant. So you then magnify that, roll it over 20 odd years, and suddenly you can see that you're prepared to pay a 50% premium for a carbon aeroplane. The operator then saves a great deal in fuel charge, and so we have a happy scenario.
And what about the effect of alternative energy sources on carbon fibre materials?
I mean, people talk about things like biofuels and so on, but that's a bit of an anomaly, because what you have with biofuels, you still have a huge cost in burn of oil to create the biofuel. And if you talk to anyone who actually flies an aeroplane about flying biofuels, is that we don't care. The aircraft operator will burn the last drop of petrol in the world, and he'll leave the farmer to burn the biofuel. And it's much cheaper and more efficient and more cost effective to adopt biofuels into tractors and cars than it is to put it into aeroplanes.
What trends have you seen in the market for carbon fibre materials?
The trends for carbon fibre materials it's really anything that moves. You know, I've even come across a carbon fibre toilet that goes in a caravan. Carbon fibre is sexy, so you see it for aesthetics in high value transport systems. You see it coming through in bicycles and wind. You see it in military, civil. You see the railways in India now working on carbon fibre. You see it in power cables. It will become a general adoptive material over the next 20 years. It will replace aluminium and steel in many instances.
And so that means we need to develop processing techniques that produce carbon fibre components in a mass format?
Yes, yeah. At the moment, the business is small. So at the moment, say the world makes 40-odd thousand tonnes of carbon fibre, and we want to grow that to about 1.5 million tonnes by about 2023. So we want to grow it 30 times over the next 12 years. But that 1.5 million tonnes is still not great. Today we produce around 50 million tonnes of aluminium and about 800 million tonnes of steel. So I would be trying to capture 2% of the aluminium market by using carbon fibre.
Right, what about the influence of nanotechnology on carbon fibre?
Well, nano is always a word that's very much overused in these days. People say, what do you mean by nano? And I always say emulsion paint. It's something that comes out of a tin. But there is more to nano. And how nano works for us is that our composites are not desperately tough. They're brittle. They break like glass, and we have to make them tough. And one route that's been postulated to making carbon composite tough is to introduce nanoparticles into the matrix system. And at the moment the matrix is like glass, and if we could have a crystalline structure, or if we could have a structure with maybe binary phases in, where we could translate energy through the matrix, better harvest the mechanical properties of the carbon fibre, that would be a way forward. And that's where we have to put our efforts. And we need to develop these new materials very rapidly over the next decade, because industry needs these materials. And if we don't have it, it will stall the industrial relaunch of our world. There isn't enough carbon fibre, and we need to put in place new types and cheap ways of making carbon fibre.
What about, do you see carbon nanotubes and being integrated in any way into carbon fibre composite materials to make a smart material, such that they can have conducting like sensors built into them?
You could do. I mean, the key that we have at the moment is to toughen the composite, and the surface area of the fibre is an area that we can exploit. And so we ask ourselves, do we want fat carbon fibres or fine carbon fibres? And if we have a fat fibre, we have great distances between individual filaments, and we can crack blunt as the crack propagates through the matrix. But we also, if we have fine fibres, we have very high surface areas. In a small composite, we would have the surface area of a football pitch, and that surface area could be used to absorb energy and inhibit failure.
In your talk that you just gave at the conference, you spoke about 3 generations of carbon fibre. Could you explain what those 3 generations are and where we currently are?
Well, the 3 generations are, at the moment, people only ever talk about growth and volume. They say to me, so what's the volume and how quickly is it going to grow? And you say, the last decade it's doubled from 20 to 40,000 tonnes, and the next decade it's going to go 8-fold to about 340,000 tonnes, and in 12 years it's going to grow from 40,000 tonnes to about 1.5 million tonne. And then they rush out the door with the good news. And they fail to stop and say, what does that fibre look like? And the answer is for the next decade it's polyacrylonitrile, which is the way we make it at the moment. But it's a very inefficient way of making fibre, and we need to have new ways of making fibre where we harvest high yields. And so the second generation of fibre are those fibres. It's fibres that are made from things like polyphenylene, fibres that are made from lignum, which is tree material, cellulose. It's fibres that we weave, and we weave our clothes. We see no problem everywhere people wear clothing. and we can weave carbon fibre in the same way. It's just we haven't done it at the moment. And so second generation is novel fibres and availability of product form. And then third generation are complex binary systems and maybe tertiary systems. So fibres that are not carbon, they could be other materials, they could be fibres that are carbon on the inside and a ceramic or polymer on the outside. They are fibres and composites that are thinking fibres, where we introduce magnetic elements, fibres that arrange themselves, fundamental building blocks. So that's what we have. We need in our research world to work on generation 2 and generation 3 composites.
So we're currently still somewhere in the halfway through generation 1 then, are we?
We're in generation 1.
So there's still a lot of work to be done,
That's
a lot
right.
of
and the
potential.
problem is that generation 1 fibres were all developed in the 1950s by the large chemical corporations of the world, and those corporations sold on carbon fibre because they weren't making money out of it, and the gestation period was 50 years and they didn't want to wait 50 years. So most of the carbon fibre businesses are owned by very small corporations, and they sell to very large corporations, and they don't have the resource to develop the new chemistry and new techniques, and that's why the governments of the world need to promote research and development into these advanced materials. And if you go back to the 1920s, you find that the governments of America and Europe, in America it was Alcoa, and in Europe it was Pechenay in France and British Alcan in the UK. It was those governments that set up the aluminium industry, and that's almost what we need to do now. And the industry that we have today and government that we have today is so short term, it doesn't think forward. And our Victorian forefathers put in sewage and water system which we use today, and we need to put in materials which our children can use in half a century's time.
So you're very much in favour of things like what they're setting up in Victoria, the ACFRF, the Australian Carbon Fibre Research Facility?
That's paramount, and what we have to do is we need to develop these materials very quickly. Now, we can individually develop them ourselves, and it will take 30 years, but that's too long. And the only way to develop it quickly is if we specialise around the world. So if here in Victoria you specialise in the development of carbon fibre, and perhaps another group develops in manufacturing technology, developing how you make composites, and a third group develops resins, and another group develops textiles, and in Manchester my group looks at testing and evaluation of composites. Then we put together this network around the world. But what we need for governments to be philanthropic, which is what Victoria State Government has done, but we need governments around the world to be more considerate of the future, and indeed industry. And at the moment industry is very selfish. Industry thinks about nothing other than the shareholder and the direct impact, the immediate impact on customer.
So you look forward perhaps to working with the ACFRF and VCAMM and Deakin University in the future to help push along the development of next generation carbon fibres then?
Oh yes, and we do. And my group is here this week at this event, and I'm here and have been alongside Dr. Bronwyn Fox and Brad Dunstan in pushing this forward.
Right then, Andrew, well, we hope that you do generate some positive collaborations between yourselves and colleagues over here, and we'll speak to you in the future with some future developments.
Okay, thank you very much.